Yeah, so this is a paraboloid which opens on the y-axis. Like that. I mean, if I wrote z equals x squared plus y squared, you hopefully would have noticed by now that that's a paraboloid which opens up the z-axis, right? So here y is playing the role z did in the usual paraboloid. So it's just a sideways opening paraboloid. But, of course, we could take this and trade this for a level function, f of x, y, z, equal to x squared z squared minus y. It's the level 0 function, right? What's the gradient of f? 2x minus 1, 2z, right? Plug in the point that we're interested in, which was what? Yeah. And what do we get? 2 minus 1. That didn't have to happen. It's kind of cool that it did, though. I mean, generally speaking, when you do this kind of stuff, it just has to be a scalar multiple of the other thing. It doesn't have to be the same vector. But this time, it just happened to work out that way. No cross product, right? We just eliminated the parameters and took the gradient of the level function, found the normal. Which is easier? I don't know. Depends on the example. These are different flavor choices you have. So I realize there's a lot of moving parts here, right? So I'm just trying to show you the different sides of this thing, right? There is yet another viewpoint. You're like, oh, yay. I was discontent with learning 2 new ideas. I really wanted to learn 3 new ideas today, so thank you for that. Well, you're welcome. So the other viewpoint, of course, is a graph, right? We can talk about a graph. So what's a graph look like? Z equals to f of x, y, right? So, you know, my picture for graphs kind of tends to look like my surface picture. But here you go. I mean, a graph is just what? It's really just a specific kind of surface, right? Graph. You could look at it parametrically, or you could look at it as a level surface. How would we look at it parametrically? How do we parametrically describe a graph? How about this? X equals to u, y equals to v, z equals to f of u comma v. In other words, we use the parameterization r of u, v is u comma v comma f of u comma v. That is a parameterization of the graph. In other words, just use x and y as your parameters. Parameterization. Yay. Or, how about we can take this graph, right, and we can look at it as a level surface. How would we look at it as a level surface? How do we look at a graph as a level surface? Well, we've got z equals to little f of xy. How do we rewrite that as big F of xyz equal to something? Some equation which captures the graph as its solution set. I'll start you out. Z blank equal 0. Fill in blank for me. Welcome back. Ian, what goes here? A variable. A variable. Minus z. Minus z. True, but so very, very wrong. All right, so you guys are teaching me not to ask you questions. All right, I guess I'll accept my lesson for today. So minus f of xy, how about that? This equation has the graph as its solution set. So you want to find the tangent plane to the graph at a point, yeah? Suppose we're at the point x naught, y naught. We want to find the tangent plane to x naught, y naught. I mean, y naught, right? Find the tangent plane there. What is it? So if we calculate the gradient of f, right, then that's what? It's minus partial f partial x, right? Minus partial f partial y, 1. And that point, excuse me, is this, you should question, is that point x naught comma y naught? It's a point in 3 dimensions. This is garbage, right? The point down here is x naught comma y naught comma 0. But this is a point on the graph. So the third coordinate should be what? Z naught. But better yet, how about f of x naught, y naught? But z naught, you could call that z naught if you wanted. But you should understand that the value of the function fed the point x naught, y naught. So what's the gradient of f at that point? We get what? Minus f sub x at the point x naught, y naught, minus f sub y at the point x naught, y naught, and then 1. So what's the equation to the tangent plane at a graph? So that tells us that the tangent plane has what equation? We have minus f sub x at the point x naught, y naught, times x minus x naught, minus f sub y at the point x naught, y naught, times y minus y naught, and then plus z minus f of x naught, y naught, equal to 0. That's the equation of the tangent plane to the graph at the point x naught, y naught. Let me write it again over here and rearrange it ever so slightly. So we just found 0 equals to minus f sub x at the point x naught, y naught, times x minus x naught, minus f sub y at the point x naught, y naught, times y minus y naught, minus z, parentheses really, f of x naught, y naught. Did I forget my parentheses over there? I might have. That's equal to 0. Let's solve that. Let's solve it for z, right? To be fair, if we want to look at the tangent plane to a graph, shouldn't we look at that tangent plane also as a graph? In other words, to solve for z equals stuff, that would be a graph, right? Solve this for z, what do you get? I might have made a mistake over here. It's supposed to be, oh, it should be this. I'm sorry, because it's 1, right? Times, yeah, you're right. It should, so, yes, thank you. So we should just have this as plus, basically. I can get rid of the parentheses. So solving for z gives us what? We get z, this is the graph. This is the equation for the tangent plane. We have z is equal to f of x naught, y naught, right? Plus what? Plus, I'll use the other notation, partial f partial x at the point x naught, y naught, times x minus x naught, plus partial f partial y at x naught, y naught, y minus y naught. What's that?
Just keeping you on track here.
Okay. This is the equation. What are you up to? This something. Oh, you're telling me it's 2 o'clock, huh? That's right. Insane thing. So, this is the equation of the tangent plane. Do you reckon? Does that look familiar to you? Compare this to the equation for the tangent line in one dimension. Y equals f of x naught plus f prime of x naught times x minus x naught. See? It's the natural extension of the tangent line for two variables. That's the tangent plane as a graph. So we have these three competing viewpoints: parameterization, level surface, graph. They each have their merits, and they're related. They're not mutually exclusive. You can transition from one viewpoint to the other. Well, guys, do bring your homework tomorrow. All right? Jonathan, did you stop it, or?